Okay, so on the back of the division template, flip it. When we are looking at a word problem, what do we have to do first, after we read it? After we read the problem, Jack?
Figure out the dividend and divisor.
What if there's not a dividend and a divisor? Because it's not a division problem. What do we have to do when we read a word problem? Does it say before you start the word problem, this is going to be a division problem?
No. Key word.
So first we have to figure out what kind of math problem is this? What 4 kinds of problems do we know how to do? Add, subtract, multiply, divide. Okay? So here's something, kind of a thought process you can go through. When you look at a word problem, I want you to think, write this on the back of that piece of paper, does it give a total? Does it give a total? Do you have something? Does it give a total, or are you looking for a total? Does it give a total? If it does give a total, what does that tell us about the problem? If a total is given, what kind of problem could it be? Harper? Subtract or divide. If it gives you a total, then that means it has to be a subtraction problem or a division problem. Okay, what if it doesn't give you a total? What if it asks for a total? Haley? It would have to be multiply or add. Okay, and again, today we're focusing on, oh my goodness, that's not what I wanted to do. Today we're focusing on fractions, but this is true for any word problem. Okay, this is true for any word problem. That gives us a 50-50 guess now. And usually when we're looking at a problem, we know it's either like multiply or divide. But sometimes the wording of those two gets funky. So if you look at it as does it give me a total or does it not, if it's giving you a total, that means it has to be a subtraction or a division problem. Because we already know that's the end point. We already know what we have, the total. If it's asking for one, it has to be an addition or multiplication. Okay, so again, today we're just doing fractions, but that's true for all word problems. Now, what we're going to do is we're just going to work through several examples together. When you read word problems that involve fractions or even decimals, my suggestion is when you read through it, don't read the fraction or the decimal. Just focus on the whole number. It helps us process the problem a little bit better. So for example, I'm going to read this 2 different ways, and I want you to tell me which way sounds easier. As part of her marathon training, Francesca ran 16 1/4 miles yesterday and 7.5 miles the day before. How much farther did Francesca run yesterday than the day before? This is kind of an easier one. But let me read it a different way. As part of her marathon training, Francesca ran 16 miles yesterday and 7 miles the day before. How much further did Francesca run yesterday than the day before? Now, does it give me a total?
No. Yes. Well, yeah.
Why is this one kind of weird with that?
Yesterday's the total.
So it gives me yesterday's total and it gives me today's total.
You have to find the difference.
So this one, does that help me if I'm trying to pick out totals?
No.
Nope, because this one gives me 2 totals. It tells me the total amount she ran yesterday and the total amount she ran the day before. But then which words tell me what I'm doing? What words up there give me the words that I need? Naomi?
How much?
Not how much farther. How much farther tells me we're going to be doing what?
Subtracting.
Subtracting. And it says yesterday than the day before. So it's yesterday minus the day before. So I want you to write down that mixed number subtraction problem and work it out. You're just doing this on the back of your paper, sorry. And go ahead and number this one number 1. We're just going to get through as many as we can. Nate, what do I need before I can add and subtract fractions? What? Need what?
Them to be even.
What do you mean by even? No, not the whole numbers. What has to be the same to be able to add and subtract, Cooper? The denominators have to be the same. We need a common denominator. Stella, what'd you get as your common denominator?
4.
4. So she left the first one the same. The other one she did times 2. Is my answer. Why can't I get my answer yet? Sophia?
Because you can't do 1 minus 2.
Okay, we can do 1 minus 2, but why is our answer in this problem not going to be negative? Because the whole numbers are 16 and 7. So I know my answer is not negative because next week, possibly the week after, I'm going to expose you to negative numbers. But, yes, yeah, weekly worksheet, I'm already trying to lead you in that direction with, what do we call them? Integers are positive and negative. Okay, good. See, you guys do retain some stuff. See? Okay, so Sophia's saying in this problem we can't do 1 minus 2 because we know the answer is not negative. So what do we have to do, Soph? Oh, other Soph.
We have to cross out 16 and 15.
Okay, so we're regrouping one whole. How do we add it on?
You do 1/4 plus 4/4.
Okay, plus 4/4 because that's one whole. So we have 5/4 minus 2/4. Sophie, take over. Now what?
4 plus 1 is 5. So then you do 5 minus 2, which is 3.
3. The 4 stays the same. 15 minus 7.
4.
Nope.
18 or 8.
8. Yep. So 8 and 3/4. 8 and 3/4. That's probably the hardest type of subtraction mixed number problem they could give you. Why?
Because
You had to regroup. If I had to guess on a 6th grade test, they wouldn't give you any that you didn't have to regroup for subtraction. Okay, so I'm going to type that one in. 8 and 3/4. 8 space 3/4. I know. It's thinking about it, I think. Sometimes it... I didn't hit enter. Just takes it in there. Now my bubble came back. Yep. Now it's going to let me. Okay. Next one. On Friday, Karen sold 5 pitchers of lemonade from her lemonade stand. I'm going to read this one as is because there's not a whole number. On Saturday, she sold 1/3 as much as on Friday. How many pitchers of lemonade did Karen sell on Saturday? I want you to write down what you think the problem is. Write down the math problem you think we have to solve. I don't want you to start solving it yet, just in case you're wrong. So, on Friday, Karen sold 5 pitchers of lemonade from her lemonade stand. On Saturday, she sold 1/3 as much lemonade as on Friday. How many pitchers of lemonade did Karen sell on Saturday? Who thinks they know what math problem we're doing here? Nolan?
5 minus 1/3.
Nope. That's why we're doing these, because we just don't have experience with them. Jude?
Divided by 3.
Technically, I'm going to say no. Nate?
5 times 1/3.
Why?
Because she sold 1/3 as much.
Okay, so it says 1/3 as much. I'm going to underline this. 1/3 as much as Friday. I want you to write that on your paper. 1/3 as much as Friday. But then what did they tell us about Friday?
Total 1/3.
Yeah. So, no, Friday she sold 5 pitchers. So 1/3 as much as 5. 1/3 as much as 5. What could I replace as much as with? What 2-letter word could I replace that with and it still makes sense? 2-letter word that I could replace all of those words. Of. 1/3 of 5. Did she make 1/3 of 5 gallons? Yes. Of means what? Multiply. So does as much as. Okay, that one's just, we don't see it as often. So 1/3 times 5. And this is why, Jude, I said technically no. But when we solve this, what's our final answer? Well, before we flip it to a mixed number. 5/3, which Jude said take 5 divided by 3. So technically, was he wrong?
No.
Technically, his math was correct. Okay, so 5 over 1, so that would be 5/3. 1 and 2/3 pitchers. How did I know my answer should be less than 5? How did I know my answer should be less than 5? Sadie? Because she made 1/3 as much. What would it have to do for it to be higher than 5? Nolan?
Like 4/3.
Be over 1 whole, yes. Okay? So this one is 1 and 2/3. Great job. I'm so smart. Okay. Dale and Francesca, they like Francesca apparently, they keep using Francesca, are collecting clothes for a clothing drive. Francesca collected half as many clothes as Dale. If Dale collected half of a bag, how many bags did Francesca collect? So, Francesca collected half as many clothes as Dale. If Dale collected half of a bag, how many bags of clothes did Francesca collect? Cooper, what's my math problem? What are my words that should be popping out at you? Livy? Okay, so I'm going to write right here. Half as many as Dale. I'm going to write that. Half as many as, I'm just going to put D. Do we know how much Dale collected?
Yes.
How much did Dale collect? Half. So I'm looking for half as much as half. What math do I do? Sophie?
Multiply.
Multiply. So for this one, we just have half of half. which is 1/4. Half of half is 1/4. Is that what you were going to say?
No, I was just going to say that it's 1/4 because it is.
Okay. Super. The chef of a pizza place used 8 packages of pepperoni and half a package of sausage. How much more pepperoni than sausage did the chef use? No writing this one down. Jalen, what do we have to do? Tell me what we have to do first, and then I'll let you go. So they used 8 packages of pepperoni and half a package of sausage. Listen to the problem. Okay, the chef place used 8 packages of pepperoni, half a package of sausage. How much more pepperoni than sausage? What do we have to do if we're finding how much more? Subtract. Nate, what is 8 minus half?
7.5.
His name's Nate. Your name's Ethan. Let him use his brain. What'd you say?
7.5.
7.5. That's not what you started to say. Okay, go, Jalen. Okay, I want you to try this one. I'm going to let you read it. You read it, you work it. Start to finish. You read, you work.
Wait, can I start going into the next section?
Yeah, you can go over on the other side.
Yeah, this is 6th grade, isn't it?
Yes.
Yeah, where's the other 5th?
Robin's room. Robin and Amanda have them.
Maybe it's like
For those that are stuck, who can tell me my words? Dane, have you already worked this all the way out? Haley? So all like, so 9.5. Oops. 9.5 times as much as what? As Felipe, who, yes, then we would replace that with 7/8. So what does that tell me to do, Reese? 9.5 times as much as 7/8. What math does that tell me to do? Yeah, so on your paper you should be multiplying 9.5 times 7/8. Just wait. Carter, do you already have this done? Who can tell me why 9 7/16 is a common wrong answer? 9 7/16. Why is that a common wrong answer? Chase, what did I do to get that?
Because I multiplied the 2 fractions and then just added them.
Yeah, multiplied the 2 fractions and just left the whole number. Doesn't work. Doesn't work. Try it again. So what do we have to do? We can't multiply mixed numbers. What do we have to do? You did it yesterday. Livy, tell Cooper what he has to do.
Turn the mixed number into improper fractions.
Improper fractions. I'm sure you weren't the only one. I didn't even notice you did it, but that's a common wrong answer. Max, what should my next step look like? What should my next step look like?
Do the wheel.
Okay, so what, like, to read me what my next step should say. Shh.
19 over 2 times 7/8.
Okay, in a nice world, what would happen here? We could cross reduce. Can we cross reduce here?
No.
Nope. Bryce, what's 19 times 7?
144.
Do you guys, I disagree because
I did 33.
133?
Yeah. I got 130.
Nolan, is that a good final answer?
No.
Why not?
Because it's an improper fraction.
Okay, when you flipped it around, what did you get?
8 and 5, 6.
Do you guys agree?
No, 5. You said 5, 6. It's 5, 16.
Oh, yeah.
8 and 5/16. Okay, hey guys, everybody stop talking. Less talking, more working. How do we get 133/16 to 8 and 5/16? Livy. 133 divided by 16. A lot of you guys try to do everything mentally and it's not working out for you. Guess and check. What is 15 or 16 close to?
Oh, 160.
We could count by 20s. How many times does 20 go into 130? Hey, I forgot you guys are all perfect, right? Okay, hey guys, we're going to nix all of that right now because 1, it's rude. 2, you all mess up. Okay? If you get the wrong answer, that's okay. Because what do we do then? We fix it. You're all going to be wrong. We're going to be doing a lot of this over the next 2 weeks. You can't just keep shouting out and being rude to each other. Okay? So that stops right now. If you want to answer, please raise your hand instead of shouting it out. If someone gets it wrong, it's not your responsibility to be like, ooh, ooh, ah, ooh. Okay? That's called immature. And we're working past that. Bryce, how many times do you think 16 goes into 133?
8.
So if we go out to the side and do 16 times 8, we get 128. We have 5 left over. So 8 and 5/16 is correct. Next one. An electrician needs 1 3/4 rolls of electrical wire to wire each room in a house. How many rooms can he wire with 3 1/2 rolls of wire? An electrician, and I'll read it without the fractions now. An electrician needs 1 roll of electrical wire to wire each room. How many rooms can he wire with 3 rolls? What kind of math problem is this?
I have a question.
Jude?
Does it want like the exact amount or
Yes,
just like
the exact
so,
amount.
like even with like fraction by?
Yes.
Okay.
Yep. Because can you use a fraction of a roll of wire?
Yeah.
Yes. What's my math problem here? Stella, what do you think? So an electrician needs 1 roll of wire to wire each room in a house. How many rooms can he wire with 3 rolls of wire?
Multiply or add?
Nope. Chase?
Divide.
Why?
Because you have to find how many rooms.
So we have a total of 3 1/2 rolls of wire. We're splitting it into pieces that are 1 3/4. So yeah, we have 3 1/2 divided by 1 3/4. 3 1/2 divided by 1 3/4. What do we do first, Soph? Yeah, we have to mix numbers into improper fractions. So what will my next step look like, Sophia?
Would do times 3 times 2 plus 1,
Which would give me what?
which would get you 7.
So we have 7 halves divided by other one. Jalen, what would the other one be? Bryce. Zip it. 7/4 is correct. Okay, then what would we do, Jalen? So multiply by the reciprocal, keep the first one, flip the second, change to multiplication. Why do we like this one, Ethan? We can cross reduce, and really the 7s, divide by 7, they're just 1, so they kind of cancel out. Can we cross reduce the other way? Yeah, or if we go straight across now, we have 4 divided by 2, or 4 over 2. What's 4 divided by 2? 2. So it doesn't matter how you get there, you would get to a final answer of 2 rooms. We're going to stop there. Do not put this piece of paper away till I look at it. Should be an easy completion grade if you copied all the problems down.